Hi, this is Mike at Gamefromscratch, and today we're going to be looking at creating and using Spritesheets in LibGDX. We're also looking at something called a TextureAtlas. First and foremost, it's probably a good idea to understand what a Spritesheet is if you've never encountered one before. As we already saw, a sprite is pretty much an image with some motion data attached. So you've got a texture, you draw it on screen, that's your sprite. A sprite sheet is a collection of sprites, all from a single source or single image. The big reason why you do this is for performance. Behind the scenes, OpenGL is being used by LibGDX. In order to draw an image, you have to do something called a GL texture bind. And binding a texture is slow. It's not astronomically slow. We're talking in milliseconds here, but as far as things go, drawing performance things go, switching between textures is a rather expensive thing. So having all of your textures come from a single, have all your sprites come from a single texture is a very handy performance optimization trick. Also, it's easier to make things, it makes things load faster because you're only loading once as opposed to multiple different images. And it also makes things a little bit easier to organize because all your sprites are together in one file. So pretty much what you try to do is group as many sprites or many common sprites together into a single bigger image, and then we load that image. Let's actually go through the process of doing this. It'll probably make a lot more sense if I show you. First off, let's create our actual game sprite. Let's do it from the very beginning. Alright. So here's a 3D model in Blender that I've done up in the past. You can actually get this source file you want from Gamefromscratch.com using this link, bit.ly/1 lowercase w 6 lowercase k uppercase d uppercase g uppercase u. You can go ahead and download this blend file. Then all you really have to do is come in and do a blend, do a render of it, and it'll save them all to the temp folder on your computer. Once again, if you click that link, it'll actually show you how to go ahead and use this. But let me just show you what we've got here. Pretty much, it's just a sequence of animations showing a rotation about the center for our sprite. And we'll go ahead and render that. Render the animation. Actually, you know what? Let's create it a bit bigger. Alright. So now let's go ahead and render that instead. Alright, they're all rendered. Now if we go back to this output directory, which is right here, you'll see now we have a sequence of sprites. You could, using your code, load each file separately and assign one to each frame of animation, but as I said earlier, that would result in 19 different texture binds as you flip between them. It's very slow. So instead what we want to do is merge all of these guys together into a single sprite sheet for our use. So let's just grab each of the files we generated and we'll copy it into our folder. So ultimately, in our assets folder, I'm going to create a directory called sprites and paste these in. Now, one of the key things is when I created this project and when you create your project, we're going to actually be using a texture packing tool that ships with LibGDX. In order to get that tool, you need to check this box when you create your package. So when you're creating your new project, make sure you enable tools. Okay, so now that we have our sprites in our project, I'm going to back up here one folder and create another folder called Sprite Sheets for future usage. Now let's flip over to our loaded project. Alright, so when you flip down here, you should see in the tools, if you expand it out, there's a tool here called TexturePacker. And that's what we want to go ahead and run. We want to run this class from that package. TexturePacker is what's going to take all of our images and merge them together into a single image. So let's go ahead and do a run on that one. So right click. In Eclipse you can do this as well. The process is slightly different. If you saw my earlier tutorial on using Eclipse, it actually shows you how to run a package, not necessarily this one, but you can refer back to it. Go ahead and run that guy. You set your working directory to the, let's see, we want it to be the Android Assets folder, like so. And we want the module set to our desktop project. Now this guy takes a couple of parameters. At the very least, it takes the folder that has the sprites, the source sprites in it. So that is Sprites, and it takes the destination folder, which is Spritesheets, and then it actually takes a name. We'll go ahead and call it Jet Sprites, like so. All right, and in theory, I've done this right. Go ahead and run it. I didn't set up the SDK on my Android project. You've probably seen this many, many times if you run through these tutorials. All right, with that set, now I'll go ahead and run. This might take a sec. I'll just go. All right, you'll see the output. There it is, writing out all of the sprites. So now we'll go back to our Android assets folder, our sprite sheets. I now have single images. 1, 2. Why did I? All right. Well, all right. Not exactly the logic I wanted, but we'll go with it. I made my sprites a little bit too big. So what it's done is it's decided how to optimize them for us. So there's an important project here. But anyways, when you run this program, it goes through your sprites and then turns them into sprite sheets at the best of its ability. And then it creates something called an atlas. An atlas is essentially a table of contents that tells LibGDX how to draw your sprites from the different images. So like here's, for example, the second sheet it created. It's got a couple of the animation frames on it. So we go back to the atlas for the second frame. It says that it's in this file. The file has these dimensions, and here is the coordinates for each actual frame we want to draw from it. So an atlas is kind of like, again, an index or a table of contents that tells it how to read the sprites from the sprite sheet. Now, instead of doing all this, we don't want it to create this many files. Let's change the settings up a bit. And one thing it's got right here is it's doing 1024 by 1024. In order to create the settings that TexturePacker uses, you create a file in here called pack.json, which is JavaScript object notation. It's a very simple data file format. You can set a number of parameters. What we were going to want to do is set the max width to 2048 and max height to 2048, like so. This will create our, this means when it's generating our texture images, it's going to create one that's 2048 pixels by 2048 pixels at the maximum. When dealing with sprite sheets, generally you'll want to keep it 2048 or smaller. Modern hardware goes up to 4096 or even 8196 in size. However, some GPUs don't handle it well. I know the integrated HD 3000 and possibly HD 4000 from Intel do not support 4K textures. So in that case, and a lot of older Android phones definitely do not support it. 2K, or so 2048 by 2048, is probably the safest, support as many devices as possible format you can size you can pick. So let's go ahead and run it with these settings. So we create this pack.json file in the folder where our sprites are being generated from, and then just go ahead and run that instead. And now it's done it into 2 sprite sheets as opposed to. So our atlas again is a table of contents where each frame is, and then we have a pair of generated images that are our sprite sheets. All right. So those are added to our project in the Spritesheets folder. So once again, you put all your sprites into a directory. You create a pack.json if you have any settings. As you saw, the original results weren't great. So this allows you to actually control what settings you want TexturePacker to use. In terms of the entire set of commands, if you go over to the LibGDX website for the wiki for TexturePacker, you can actually see what the settings are and what their defaults are. Another important one, and this one is somewhat outdated with the newer versions of OpenGL, but still a good idea, is POT, or power of 2. Power of 2 straight up from math, like 2, 4, 8, 16, 32, 64, and on and on, are ideal sizes for working with textures. It used to be with OpenGL ES1, it had to be a power of 2. That restriction is gone. However, power of 2 formatted textures load faster, draw faster, and are better to use. So even if you've got dead space or empty pixels, you're probably better off using one of the power of 2, so 512, 1024, 2048, 4096, etc. Dimensions in one direction. Now, it doesn't have to be a square, so you can have 2046 by 1024 or 2046 by 512 or whatever fits for you. Just try to stick with power of 2. You'll work on the most devices as best as possible. It's not a requirement like it used to be. However, it's still a good idea to get into this pattern. So here are the various settings available. Again, you can come and look up the site. It's easy enough. So now let's jump in and get the code. And once again, as you saw first off, you do not need to create a pack.json. It's just sometimes the results that it creates are not optimal. All right, so now that we have our texture file, let's go ahead and see how to use it. Let's go over to our code. And we're going to use a couple of things here. Let me just flip into presentation mode so this should be easier to read. Okay. So we are going to need TextureAtlas. This is, again, that table of contents type file. TextureAtlas is the object responsible for reading that. We'll call it TextureAtlas. We are going to need a sprite to draw our texture, and we're going to need something called a TextureRegion, which identifies a portion within the TextureAtlas. That should be it for now. So let's go on back. First thing first, we'll load our TextureAtlas. Now, once again, you just use normal libgdx input-output command, so gdx.files.internal, and then it is in the folder Spritesheets, and it is called Jet Sprites Atlas, I think. Let me just verify that. Alright, it is here, and it is called jetsprites.atlas. Alright. So we load our TextureAtlas, and then we'll create a region. TextureRegion equals atlas.findRegion, and we find it by name. Now this is a key thing to understand and how this worked. If I go back to our TextureAtlas, I really got to find the hotkey for that command. Right over here, you'll see each one has a key. So 001, 002, 003. That looks like it's a number-based index, but it's actually not. When I went ahead and rendered these things, you'll notice the file names 001, 002, 003. So when TexturePacker pushed them all together, it used their file names for the index within the TextureAtlas. So if you've got a sprite like a walk left, walk right, jump, so on and so forth, make sure you name it appropriately. So if you have like a 5-frame animation of jumping, call it jump 01, jump 02, jump 03, etc. And those will ultimately be used for the keys within the atlas. And then you will use them to find out where that region is, like you've done here. So now we finally go ahead and create our sprite. Equals new sprite. But instead of passing in a texture, we pass in a region, like so. Finally, let's position our sprite centered. GDX.graphics.getWidth. I'm being lazy today, so no camera. Alright, so we draw our sprite centered. Finally, let's change out our draw code here to like that. Okay, so essentially what we've done here is we created our TextureAtlas using the file. We then find out the location of the texture region by calling findRegion, and then we create our sprite using that particular texture region. I need to create a new run profile because this one is currently set to run TexturePacker. So run, edit configurations, create a new one for application. Create the assets folder as our run directory. desktop as our module, and finally desktop launcher as our main class, and apply. And now we find out if I made any mistakes. There you go. There's our first frame of animation drawn, sorry, our first sprite frame drawn center to the screen with that ugly, ugly red color. Let's get rid of that for future use. So now what you obviously want to be able to do is flip between frames. So let's go ahead and do that. So we'll add it so that as you add up and down arrow keys, it'll switch between them. So that's just a matter of implementing our input processor, my little light bulb, implement all those methods. I'm not going to forget to do it this time. Register our input processor like so. And finally on key down, oh, sorry, we're going to need a couple of variables here. First thing I need to do is track current frame of animation. And then we're going to have, we have 19 frames of animation, starting at 1, going to 19. So there we go. All right. Now when we hit key down, what we basically want to do is flip through all the animations. So if we go from key 0001 to 0002 until we hit 19, at which point we roll back over to 1. We're going to do that on key down, and then we're going to do the exact opposite. So if we get to 1, we flip back to 19. So in order to do this, we simply do if key code equals keys dot. Do I want up or do I want down? Up. All right. Then increment our current frame. If our current frame is greater than max frames, current frame equals 1, like so. Now finally we update the region of our sprite, and that is done via sprite.setRegion, and you can do this by passing. Oh, we have to get our texture region from the atlas. So find region, and we pass in the name. Now the problem here is we're dealing with a string value, or sorry, an integer value, and we want to pass in a 4-digit string value. So we just do string.format, and then we want 4 digits, like so. And we want to do current frame. That's enough. Yeah, there we go. And we handled it, so we return out true. Now I'm going to get myself in trouble here. Do some cut and paste coding, which never works out well. All right, why are you not resolving? You're supposed to auto-resolve. Alt-Enter. All right, so in this case, we want to decrement if it's less than 1, and then we set it to max frames, like so. Otherwise, your logic is consistent. All right, so now we'll be flipping through the region as we use the up and down arrows. As long as I didn't make a mistake, which since I copied and pasted, I almost certainly did. We run our code, and now I hit the up arrow, and then down arrow, and it does absolutely nothing. All right, so I did make a mistake. 1 second. Yep. All right, I did a classic cut and paste error. So basically what I just did is if I hit key up, go ahead and increment, and then I come in here and then do if key up, and then decrement. This is why cutting and paste is bad, folks. All right, there we go. That should fix it, and it should now run right. Let's see, it's not running. There we go. Go ahead and run it. If I press the up arrow, we go that way, and if I press the down arrow, we go that way. So that is how you can use a texture atlas and a sprite sheet for multiple frames of animation in a very good, well-performing way. And it doesn't have to be animation by any means. You could have all of your likewise sprites drawn in together. So if you had a 2D role-playing game and you had tiles to make your gates and your grass and your water, etc. Totally makes sense to group all these together into a sprite sheet. Best performance you're going to get comes from going that route. So that's pretty much the basics of using a texture atlas and a sprite sheet in LibGDX. So let's go through the code one more time. So what we basically do is come in, we create our texture atlas by loading the .atlas file that we generated using the TexturePacker utility. We then set a region by name, the keys being created from the file names that were passed in. Then we create our sprite using that region. A texture region simply tells LibGDX to draw from this coordinates at this location within this sprite, within this texture to create this sprite. And when you switch frames, you just simply call sprite.setRegion and set it to a different region within the texture atlas. There's other ways you can do this. You can increment up through them. Come in here, you'll see you have a number of options. You can create regions yourself. You can set values yourself. You could have also, instead of getting the region from find region, you can do TextureAtlas.find. You can pass in the index you want. I believe you can also do it by dimensions, but I'm not going to cover that right here. So basically, yeah, that's the process. Now, one thing that you may not have liked was the TexturePacker program we used to get in here. It's a command line only utility. Coincidentally, you can run it from the command line. The nice thing about that is you can set it up so that it runs as part of your build process. You can even run it from code if you'd like. So if you want to have all of your sprite sheets created when you run your app, you can do that using this. However, you may find that you don't really want, if you're only working on a couple, it's kind of an unwieldy way to do it. You got to set in the parameters, set up a run profile, whatever. There are also applications out there that are pretty good fit for creating textures, and one of the ones I use most commonly is a program called TexturePacker from a company called Code and Web. TexturePacker is very easy to use. I already have it installed, and I'll show you the process right here. TexturePacker. So as you see, you can go ahead and use the free version. And then you just come in, pick the framework you want to run with, and this will configure the settings for you, although there are some changes you need to make. Remind me later. So then you just simply take your frames of animation, and you drop them into the program like so. Then you probably want to set power of 2. Cause is consistent here. The one thing you want to change, your things will not work right, is your algorithm. Just set it to basic. So otherwise it starts doing some fancy stuff and then it no longer works. But basically that's all you need to do. And then once you have your sprite sheet as you like it, also I guess we want to do trim. We want all the frames to be the same size so that that was trimming out white spaces, but since I'm dealing with animation, we want actually each one to have a certain amount of white space. So in that case, you use trim mode as none. If you're dealing with just raw images, you probably want to trim, and that gets rid of all the clear space. But in this case, we actually want clear space to keep everything the same size. It's going to complain because of the size. So in this case, let's go ahead and up our size like so. So we're going to create a 4096 by 2048 sprite sheet, and then finally just go ahead and publish it. Then you've just picked the directory you want to go to. Let's put it in the root. Sprite sheet. And once again, same folder as the ping file, sprite sheet, and it's writing it out, and done. So now if we go back to our project, leave presentation mode here. You will see we now have, we now have a texture called SS, like so, and a texture atlas generated. So we just switch out to use ss.txt. And it should just run. There you go. So if you don't like using the built-in LibGDX command, there is a program called TexturePacker, and it works that easily. There are some catches there, like you saw. There was an error message basically saying it's not going to fit into the size that we were providing, whereas the LibGDX one was smart enough to split it into 2 files. This one would have just not included them. So you would either manually have to manage that thing. So there are some things that the LibGDX version does a bit better, but if you definitely prefer a UI type interface, TexturePacker is definitely something to check out. So that's dealing with sprite sheets and texture atlases in LibGDX. I hope you enjoyed that. Thank you.